Hi everyone, this is my voiceover of La Planta Tech Programming in LabVIEW videos that I originally created for my overseas audience, and now, since there is some interest from my Silicon Valley community, I decided to quickly translate it. And today, we continue exploring database management tools. In the previous episode, we reviewed login modes as well as password verification and saving for users. Today, we'll look at assigning the database storage location, saving the path, and encrypting it with storage in the config.ini file, opening databases, and managing tables. So, on the toolbar, we have the database path selection control. Let's see where it is located on the block diagram. Power off, and let's find terminal of databases location. The block diagram opens automatically. We can see that our databases location control is indeed a control, and right away let's look at what variables and properties it has. At this point, text-based programmers are still trying to remember where this control was declared. In LabVIEW, we just right-click and say Find Terminal. End of story. So we click Find, and let's start with property nodes, with the properties. The first property we see is disabled. It participates in the active-inactive logic, enable-disable. We reviewed this logic in the previous episode. The second property is visible, which participates in the login case, and we assign this control to be visible only for the administrator. We also covered this in the previous episode. The third property is again our active-inactive logic. We apply this logic to deactivate functions that are not needed in the current database workflow, and we'll come back to this later. The next property, the same thing. The next one, the same. And the next, also the same. Everything here follows the same pattern. So we'll return to this later. Now, let's look at what variables this control has, local variables. From the front panel, we select Find Local Variables, and we see that we have 4 local variables, 2 for writing and 2 for reading. Let's look at the first one. Into this variable, we receive the path that was saved in the config.ini file. Let's open our read path sub-vi and see where the data comes from. We see our standard structure here. We've already reviewed it in the previous episodes, so I'll just briefly remind you. We open the file.ini file, extract the database path value for decryption, and output it into a cluster. In text-based languages, this moment usually comes with 5 helper functions, 3 libraries, and a quiet prayer that nothing breaks. In LabVIEW, it's just wiring. This is our decoder, and using the decoder, we convert the path db string in the config.ini file into a directory that the computer understands. Okay, we can close it now. Next variable, let's take a look. This one is used when writing the path after saving for verification. Where do we use this variable for reading? Let's find out. This variable is used in the Find All Databases case when we press the Boolean button Find All Databases. Let's see where this button is located on the front panel. We've already seen it. Now let's move on to the last variable. It is used in the database in use case, when we perform a value change for DB in use. Next, let's examine save path. We find its terminal and land in the event case save path value change. Here we see the subprogram save path. If we go to visible items label, we can see the name of this subprogram. We called it sub-vi config path write using underscores. And here I want to pause and explain why I name things this way. Common LabVIEW programming practice assumes that all subprograms, all sub-VIs, are located in a single shared folder that is all part of the project. Here's my project folder, here's the sub-vi folder. I open it, and here are all the files that I use in the program. This is the moment where C++ developers ask, wait, your project structure actually mirrors your file system? Yes. Yes, it does. Now, let's open the project. On the block diagram, we go to Window, Show Project. Here I also have the sub-VI folder, and if I open it in the project, I see all the same files that are in the project folder on my computer. As you can see, all these files are part of the project. We can choose which files we want to include in the project, but if we want to include all the files, we can right-click the folder in the project and select Convert to Auto-Populating Folder. Then we navigate to the sub-VI folder, and only then, exactly here, we click Select Folder. That way, the entire folder is captured. Now this folder is auto-populating, and all files from the computer folder automatically appear in the project as well. If I want to stop auto-population, I select Stop Auto-Populating. So let's return to our Save Path case. When we press the Save Path button, the following sequence of actions happens. First, a confirmation pop-up window appears asking whether to save or not. The administrator has the option to cancel this action. If the action is cancelled, the false case executes, and we exit through the enum wait for event into the event case timeout. We stay in this case while the program is running until another event case is triggered. Now back to Save Path. If the administrator confirms the action, we go into the true case, where our variable containing the selected path is written to the config.ini file, immediately read back and output as a verification in the same window. Let's look at the sub-VI Save Path. Here we see our standard structure. We open the file for writing and reading. First, write the encrypted string into the file under the path section with the key pathdb. Encrypting database path in LabVIEW is literally drag-drop wire. Somewhere else, a developer is still Googling Best Encryption Library 2025. Let's see where it's written. We go to our project folder, open the config folder, and open the config.ini file. Here we see path and pathdb. As you can see, the path is encrypted and no one can tell where the database is located. It could be on the local computer or on a remote computer on the local network. After saving, we read the string, decrypt it, and output it to the terminal. For writing, we use the path to string and string to path functions. These functions are located in the functions menu. String, path array string conversion. We can close it. Now let's return to local variables and move to the third local variable. This one is used in the Find All Databases case, value change. Here is the button on the front panel, Find All Databases. Next, the values of this variable go into the sub-VI with the icon db find all db. Let's see how it works. Here we implemented the following logic. If database's location doesn't have a directory, meaning it's empty, we use the empty string path function. Let's look at this function in context help.
Empty string path returns true if string path is an empty string or an empty path. Otherwise, this function returns false. This function is also designed to work with variants, pictures, and DSC tags.
Next, we use the select switch. This is the function we talked about in our previous episodes. If the path is empty, it switches to the function that provides the default database path. We define this path as the application folder and the subfolder db. So if this field is empty, I've removed the path here. Then the program uses the db folder inside the project, where all our training databases are located. After the path is selected, we use the list folder function. This function lists not only folders, but also files. We can also review it in context help. We take all the files in the selected folder into a string 1D array. Using a for loop, we iterate over this array as many times as there are files. For example, if there are 5 files, the loop runs 5 times. If there are 10 files, it runs 10 times. Each file passes through the for loop and is checked using the search split string function, which divides a single string into two substrings. Each file is checked for the .mdb extension. If a file with such an extension exists, through the empty string path and not function sequence, we convert this into true. Using the tunnel mode indexing conditional, we collect only the files with the .mdb extension back into a 1D array. So this for loop acts as a filter, extracting only the files we need. In our case, database files. This for loop is doing what text-based code usually does in 40 lines, except here you can actually see it working. If at least one file exists, using the empty array and not functions, we convert this into Boolean true and output it to the terminal db exists. Using the insert into array function, we insert an empty space into the first row of the db in use window on the front panel. The final operation is deciding where to route program execution next. If there are no files in the folder, meaning the array is empty, then using the select switch again, we go to the disabled and grayed out case. If at least one database file exists, we go to the enabled case and route the selected values to the enable-disabled terminal. And here we have all inputs and outputs of our terminals in the patterns window. In context help, we can see all terminals displayed and labeled. We can also see this in our main block diagram. Context help shows all inputs and outputs there as well. So, using the output db exists, we control the true or false case. If false, a pop-up window appears saying no database found, and the execution moves to the disable controls for find databases case. If true, we disable the db in use control, making it disabled and gray, because we no longer need it. At the same time, we clear the table, which we already know how to do, and move execution into the enable controls for find databases case on the case structure. Here we enable our standard logic, we deactivate functions that are not yet needed and activate those that are required for the next step. Let's see how it works. I close context help, run the program, log in as admin, and let's say I remove the database path here and press the Find Databases button. As you can see, all buttons are inactive except for 3 that I can use at this stage. Login, the database in use window that we just activated, and the power button. This way, we prevent the administrator from making mistakes or having to think about unnecessary steps. There is really only one choice, to use the db in use window. That's exactly why we need the disable and gray logic, to simplify the work of the administrator or operator. I select the database I want to work with, and at that moment the db tables window becomes active, where I choose the table I want to work with. And once the table is selected, we see that other functions become active, and that's what we'll talk about next time. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.